Hello everyone, welcome back to my channel. Let's discuss this problem. Now this problem is related to the carbon dating. In this problem, what is given to us is that a sample of wood is given. In this sample of wood, if you see, the initial reading is 32 dpm. dpm means disintegration per minute, right? And in the fresh sample of tree, this value comes out to be 122 dpm, right? Now basically what happens in the case of carbon dating is that now every wooden sample contains both a normal carbon and a radioactive carbon, that is, it both contains C12 as well as C14. When the tree dies or when the wooden sample falls down, what will happen? This C14, it starts decaying, it starts showing the activity, and this C14 sample converts into nitrogen through beta decay. That means it releases a beta particle and it gets converted into nitrogen atom. So this is how the C14 shows the beta decay, and this is how it converts into nitrogen. Now with time what will happen? The amount of C14 will keep on decreasing in the sample, in the dead sample of the tree or the wood. So using this concept we can easily find the age of a tree. Now half-life of C14 is given to us, which is equal to 5770 years. And this carbon dating, it also follows the first order kinetics. So we can apply the first order rate equation to find the age of tree. Now one very important thing is given to us is that even after the C14 was finished or vanished from the wooden sample, the reading was still shown, which is 2 dpm. That means this 2 dpm reading is the error in the counting, right? So if you apply the formula, Kt equals 2.303 log of A naught upon A. Now what is A here? A is the activity of sample, that is carbon 14 sample at time t, and A naught is the activity of sample at t is equal to 0. That means from the moment that wood has died or it has fallen from the tree, from that time onwards A naught is the value, and from that time onwards we start calculating its age. Now here A naught comes out to be how much? For us the A naught value is 122, right? In the fresh sample of the tree it is 122, but since 2 dpm is the error, we have to subtract it from that. So A naught comes out to be 120 dpm, and A value, it comes out to be 32 minus 2, 30 dpm. Now since it's a first order kinetics, so we know the value of K will be equal to 0.693 upon T half, right? So now putting all these values into the equation, we will get the age of the tree in the terms of time. So it will be 0.693 upon the T half is given out to be 5770 years, which is equal to 2.303 log of the A naught is 120 upon A is 30. So upon solving this, now we know 0.693 is how much? 0.693 is 2.303 into log 2. Log 2 is 0.3 upon 5770 equals 2.303 log of 4. Now this log 4 comes out to be 2 log 2. Since 0.3 is also log 2, and here we also have log 2 at the right hand side, so both will cancel out. So that means also we are forgetting the time term. The time term is here only, right? So T equals 5770 into 2. This is the final age of the tree. This value comes out to be 11540 years. And if you look at the options, option C is the correct answer. So I hope you understood the concept, and I hope you understood the application of this concept in finding the age of the tree. For more such problems, stay tuned. Have a good day.